In this video, I'm going to teach you 3 additional points of concurrency besides the centroid, which you've already seen before. In order to do this, you're going to need your compass and straight edge. So if you don't have yours, go ahead and pause the video right now so that you can grab your compass and straight edge. And then let's go ahead and let's do this. I'm in the page in your notes packet where it says points of concurrency, the circumcenter. You want to be in exactly that same page in your notes packet, obviously. The directions for this ask us to use our compass and straight edge to construct the perpendicular bisector of each side of the triangle. So we're trying to construct the perpendicular bisectors of the sides. The sides of the triangle are made up of line segments. We're trying to construct the perpendicular bisector of each segment. So we learned this construction back in the fall. So this is kind of great review, great opportunity for us to practice. I'm going to start by constructing the perpendicular bisector of side or of segment AB. So let me grab my compass. Remember that in order to do this, I start by placing my compass on one of the 2 endpoints of the segment that I want to bisect. I think I'll do all of my constructions in purple for the bisector of side AB. I'm just going to draw a nice arc. Once I've got a nice arc on my paper, I'm going to flip my compass around and move the point of my compass now to the other end point, in this case point A. Draw another arc. Then I'll get my compass out of the way. I want to grab my straight edge. And I'm going to draw a nice big perpendicular bisector. No wimpy wussy bisectors for us. So that segment now represents the perpendicular bisector of segment or side AB. And now I'm going to do the same thing for segment AC. I'm going to start with the point of my compass on one of the endpoints of that segment. Remember, you can use any convenient compass setting as long as it's greater than 1/2 the length of the segment that you're trying to bisect. I don't know why my red pen was drawing in purple there for a minute. That bothered me. If you don't draw those arcs big enough, you'll have to go back and redraw them so that they are drawn in such a way that they intersect. And again, I'm going to draw a nice big perpendicular bisector. And then lastly, I think I'll do the bisector of side BC using my green compass or my green pen. So those are the endpoints that I want to use now. I think I'm going to go slightly different size than I did with the purple, just to try to keep everybody straight on my paper here. Yours is probably going to end up looking a little sloppy, a little messy because you've got a lot of arcs running around on your paper. I have the luxury of having 3 different pens that I can use to do my arcs, but you may not have that luxury. And notice that just like the centroid, or just like the medians, the 3 perpendicular bisectors of a triangle intersect at one point. We have a name for that. The name of the point where our 3 perpendicular bisectors intersect is called the circumcenter. The circumcenter has some really super neat and unique properties. But all you really need to know for this class for this year is the circumcenter represents the point where all 3 perpendicular bisectors of the sides intersect. And again, we might look at some of the cool properties of that when you come back to class. But those are the nuts and bolts. That's the nitty-gritty. That's what you need to know. Circumcenter is the point where all three of the perpendicular bisectors of the sides of a triangle intersect. All right, if you haven't finished writing, pause, because I'm going to skip ahead. I'm going to go past the key ideas on circumcenter. I'm going to go past the material on the centroid because you should already have this page filled out. I'm going to go right to the page where it talks about points of concurrency, the incenter. On this page also, it's asking us to do some constructions, but this time it's now asking us to construct the angle bisectors. So once again, I need my compass and straight edge. Let me dig out my compass. I'm going to start by constructing the bisector of angle B. And if you don't remember this from the work that we did in the fall with the constructions, now's your time to get on board. I'm going to go ahead and put the point of my compass on point B. I'm going to set my compass setting to any convenient arc length. And I'm just going to draw an arc, not too big, not too small. What's important is that that arc intersects segment AB, and then it also intersects segment BC. And I can change the compass setting if I'd like. But once again, what I'm going to do here is I'm going to go and I'm going to draw some arcs. What's important here is that when you make the first arc, using that first point as its center, you need to use the same compass setting for the second arc. So again, it doesn't matter what that compass setting is, as long as it's the same for both of those arcs. And again, I'm going to draw a nice big bisector. And then I'm going to go ahead and I'm going to repeat that construction at point A to construct the bisector of angle A, and at point C to construct the bisector of angle C. And notice that I didn't draw that first arc quite big enough, so I'm going to have to go back and extend it. Which is kind of a hassle, but it's not hard. And again, no wimpy wussy angle bisector for me. I'm going to draw a nice big angle bisector. And then I'm going to go through and I'm going to repeat this construction one last time so that I can bisect angle C. And your construction will probably be a little sloppy, a little messy looking. I have the luxury of the smartboard where I can do all of these arcs in different colors so that I can kind of keep track of which arc belongs with which angle. You're constructing all of these in pencil, so you don't quite have the same luxury as I do. So you'll have to work a little harder to make sure you can keep track of which arcs belong with which angles. My construction this time around wasn't as precise as it was with the segment bisector, because notice that my angle bisectors meet more in a little triangle than they do in a point. But if I had been super precise with that construction, they all would have met at one point. And the name of that point is the incenter. And like the circumcenter, it has some really cool properties, but what you really need to know for this year is the incenter is the point where the three angle bisectors of a triangle intersect. And I had all of that space on the page. I don't know why I put that right there. One of many different things I don't know this year. And again, the angle bisector or the incenter has some pretty cool properties, which we might discuss when you come back to class. It's just cool. Let me flip back to that page. If you're not done writing yet, go ahead and pause the video. But if you're done, let's go on to the last page. We're going to boogie past the key ideas and the check your understanding. We're going to go talk about the orthocenter. In the orthocenter, I actually have a couple vocab words to talk about on this page, one of which is the altitude. We all know the word altitude means height. The altitude at which a plane is flying is the height it's off the ground. But what we really need to talk about is that when we talk height, we always measure height at right angles. When you go to the doctor's office and they measure your height, they don't say stand sideways. They say stand up straight. They want you to form a right angle with the ground. So when we measure height in a triangle, we do the same thing. What we do is we connect the vertex of the triangle to the opposite side, but we have to do that in such a way that it forms a right angle. That's really important. So when we construct our altitudes, we need to do this in such a way that we form a right angle. So in other words, I need to go from side A to side BC in such a way that I form a right angle. Well, the way that we did perform this construction in the fall is if we want our altitude to go from point A, I'm going to go ahead and I'm going to put the point of my compass at point A. And I'm going to start by drawing a nice arc. And notice that my arc only intersects the triangle in one point because side BC isn't long enough. So I'm going to have to go ahead, I'm going to have to grab my straight edge and I'm going to have to extend side BC. You might have to also. And then what I'm going to do is I'm going to go take that line segment that's determined by those two purple endpoints and I'm going to construct its perpendicular bisector. So again, I'm just going to go construct the perpendicular bisector of that line segment. And again, remember that you can use any convenient compass setting as long as it's half the length or longer than half the length of the segment you're trying to bisect. I like to use one that's the same distance as it is from that point A to the end point. So the same as the first one, just because then I'm always sure that it goes through the point that I'm trying to bisect. Now though, I've got kind of a problem because it's so big that it's going right off the page. So that segment that I just drew with my black straight edge now represents the altitude of my triangle. It forms a right angle. Sometimes I think the smartboard's got a mind of its own. So there's one altitude. Now I'm going to go ahead and I'm going to construct the altitude from point B to side AC. So I'm going to start with the point of my compass on point B. I'm going to be a little bit smarter about how I make my arcs this time though. Hopefully if I make them the right size, I won't have to extend any of the sides of my triangle. And apparently I didn't do a very good job of that because I'm going to have to take my straight edge again and extend this time side AC. So I want the points where that blue arc intersects either side AC or the extension of sides AC. And I think in the interest of time, I'm only going to construct 2 of these altitudes. For whatever reason, I can't see the clock right now. But I feel like my video is getting long. So again, I'm only going to construct 2 of these altitudes. But if I were to construct all 3, they would meet at a point. And that point too, you guessed it, has a name. It's called the orthocenter. And the orthocenter is the point where the 3 altitudes of a triangle intersect. All right, so folks, this video is a little bit longer than I wanted it to be. However, no check your understanding questions to do today. So as always, thank you for the gift of your time. We'll talk more about the incenter, the circumcenter, and the orthocenter the next time you come back to class.